Buenos dias a todos. Hello and welcome to FOSS4G workshop from data to vector tiles in your web and mobile apps. At the beginning, I would like to introduce the team that will guide you through this workshop.
My name is Tom, and I'm geodata specialist in MapLibre team, and my main focus is the maintainer of OpenMapTiles.
I'm Peter Thorny. I'm working as a developer at MapLibre.
And I'm Adam Laza, and I'm data engineer, and I work mainly with QGIS, PostGIS. So I will show you some analysis in QGIS and PostGIS in this workshop. We all work in a company called MapLibre. In MapLibre, we care about maps, we care about data. So hopefully we will teach you something new today. What is this workshop about? Let's imagine that you are a GIS guy or GIS girl, web developer or spatial data engineer. You have some data, a shapefile, geopackage, geoJSON, whatever. You might want to edit your data and then display it in a map and have a really nice application on web or your phone. But at the beginning, you have just geoJSON and it's just text file. And it looks like a long way to that cool web application you dream about. Well, fear not, for we are with you to show you the way. After this workshop, you will be able to use OpenStreetMap data for your basemap. You will be able to analyze your data in geoJSON or shapefile and create vector tiles with both OSM and your data. We'll show you how to serve the tiles, how to add style to your map, and how to use this map in your web application. Sounds good, right? But then how to accomplish that? Is that easy? Well, actually it is. There are several open source projects that will help us on the way. We'll use PostGIS as a database, then we will use OpenMapTiles as a project that defines schema of the vector tiles. We will fiddle with QGIS to display our data and analyze them, and we will use MapLibre and MapTile Cloud to finally get that application. Okay, what will be our use case? Let's say that I'm a bike enthusiast. I'm at FOSS4G conference in Buenos Aires, and I want a web app that displays cycleways in the center of Buenos Aires. So I want a map with cycleways. But because I have a really old bike, there is pretty high chance that my bike breaks down and I will need to repair it or maybe even use a shared bike. That's why I want to add some points of interest. I want to add points with bike shops. I want to add bike sharing stations. And because I am super lazy, I want to know how far these points are from the nearest cycleway. There is a simple and, let's say, advanced solution. Here we'll show you both of them.
Thank you, Adam. So if you would start working on an application like that, you would probably start with something like using your basemap provider, and you would initialize the map viewer. So, as you can see on this sample here, you would tell the map viewer to load standard predefined style, and then you would probably load points of interest from, for example, GeoJSON data source or any other JSON source. And then you would iterate that source and create markers, put them on the map. That's kind of, a very basic solution. And if you would do it, you would basically get application like this. Standard base map with markers, and that's it. This is typical approach which many developers take. It has some drawbacks. We will talk next. For example, loading a huge data set from JSON doesn't scale. Another problem might be that the basemap which we'll use will not have the complete information you are looking for. For example, you will not see all the cycleways. So as we will go through this tutorial, we will show you either way how to do this, and we will implement application which will have customized basemap, and it will basically load all those points of interest to vector tiles, and in the end you will see something like this. So that's all for now from me, and I will ask them to go back.
Back to our use case. What do we have? We have geoJSON with bike shops in Buenos Aires, and we have a shapefile with bike shopping stations. These are open data from Buenos Aires open data portal. Big thumbs up for Buenos Aires for open data. We want to analyze the data, add the information about the distance from the cycleway. We want to have a map of cycleways, bike shops, and bike sharing station, and we want to display the map in our app, the phone, and we want to have a pop-ups so we can click on the bike shop icon and get a pop-up with some additional attributes, some additional information, for example, the distance from the cycleway. These are the steps we will show you in the workshop. First, we need to add data, OpenStreetMap and our custom data from Open Data Portal of Buenos Aires. Second, we want to modify our data. We want to do the analysis. Third, we will take these data and generate vector tiles from them. And last, we will build a web app. Step one, we will use OpenStreetMap data for a base map. You can see them on the left side, and you might find that these data are incomplete. For example, there are missing cycleways or bike shops, but we have our custom data set, which is more complete and is up to date. And we might also learn that cycleways data exist in OpenStreetMap database, but they are not included in the schema by default. And we will show you how you can add these data into vector tiles schema. Step two, we need to add an additional attribute to our points, which doesn't exist anywhere, but it's important for our use case. In our example, we want to tell the users how close is the bike shops or rental station from the cycleway. We will show you how to calculate the distance between each point and the closest cycleway, and we will show you how to include this information in vector tiles. This is something Peter talked about. While loading points in JSON from server and drawing them on the map, it works for small data sets, but it's not scalable. Your marker set might grow over time, and your users might experience performance issues as the app needs to download the JSON file, parse it on the client, and render all markers. There are solutions to solve this problem, for example, clustering, but we will show you how you can use the power of vector tiles. The tiling schema partitions the map space, and you only request data from server, which are relevant for the actual map extent and scale. And since we use vector tiles, you can still access attributes and present them to the user. And our final goal, let's build the web app and mobile application, which makes use of the improvements we have just described. We will focus on the web app. We will show how you can host the vector tiles you have created, how you can use it in the application, and how you can display its attributes. We will also show how you can use your custom map on mobile device using MapTiles mobile app. You can also reach out to MapTiles docs site where are tutorials showing how to build app with your custom map for iOS or Android. About the organization of the workshop, it will be split into 4 blocks. Each of us will guide you through one of the blocks. Between the blocks, there will be a few minutes break to refresh, catch up, ask any additional questions. And we'll start with block 1 about data from OpenStreetMap. Some useful information. We created a GitHub repo where you can find all source code, input data, analysis results. There is also a README file that describes the whole process step by step. So even if you get lost or something, in the README file, you can go and step by step see what you should to do. We also have a FTP server where all input data, analysis results, and these slides. So it's on dev.maptiles.download/FOSS4G. You have to log in as user FOSS4G, and password is Buenos Aires 21. During the workshop, we will use few services that requires you to create an account. But don't worry, everything is free, and you need just a Google account. So please create an account at cloud.maptiles.com and stackblitz.com. And if you are not using Linux, please also create an account on the cloud.google.com because we will need it. Yes. Our main concern is about what operating system do you use. If you use Linux, please install Docker and Docker Compose. There are links on the slides to the docs from Docker. And if you have OS X or Windows, please create an account on the Cloud Shell and sign it with your Google account. And as you can see on the picture here, if you sign in, there is an option console, and it will create a small virtual machine for you, and you can work with us. Also, we need to have QGIS installed. Make sure that you have version 3.16 or later. If you are installing now and you are on Linux, make sure that you install also QGIS plugin grass package. And information how to install the QGIS is on the link provided here.
I hope that everyone is prepared and finish preparation for this workshop. My name is Tom, and I will guide you through the block 1, where we extract data from OpenStreetMap and do the first step in our goal for this workshop. Our goal is then take the OpenStreetMap PDF file from Buenos Aires city, then use OpenMapTiles project where we add new extra layer into this project, and the final result of the first block of whole workshop is to have PostGIS with full of data from OpenStreetMap. These are the steps. The main 3 steps how to accomplish this block 1 is to download and set up OpenMapTiles project, and I hope that everyone was able to pull Docker images, but I hope that that's okay, and we will pass through in this block. The second step is create extra layer into the OpenMapTiles project, where we add three main new files: mapping file, configuration file, and SQL files. And the last step is import the downloaded OpenStreetMap from the first step into the PostgreSQL. But first of all, I would like to introduce OpenMapTiles project. OpenMapTiles project is open source projects which allows you to convert OpenStreetMap or any other spatial data from PostgreSQL to vector tiles in MB-tiles format. There are basically two projects, OpenMapTiles, which define a schema. Schema defines which data will be shown in particular room and in a particular way, the best way. And the second project is OpenMapTiles tools, which contain all tools necessary for import OSM or any other data into PostgreSQL, and even generate the tiles itself. If you would like to know more about OpenMapTiles, please came at Friday on my presentation from 10 a.m. in Buenos Aires time. OpenMapTiles have seven makefile targets which run through whole project from download, which download data from OpenStreetMap, basically from GeoFabric or OSMR or your URL or any data source. Then there is make target import data, which imports stable data like nature Earth data, which are used for upper zoom levels. That means zoom level 0 to 4 or 5, depends on layer, up layer. The third make target is import borders, which borders are taken from the spatial another project and are extract from downloaded PBF file and import into PostgreSQL. The fourth step, or make target, is import OSM, which import data from the PBF based on mapping.yaml files. The next step is four steps. Make target is import Wikidata, where we can use and improve our data by import another languages from Wikidata source. The next target is import SQL, which take all SQL files from the schema and run it and import all SQL functionality and pre-processing data into the PostgreSQL. The last step, the last target is make generate tiles, which generate vector tiles. So our first step is complete. The next step is more practical. So in this first setup OpenMapTiles project, we will download OpenMapTiles in version 3.12.2. It's last stable version. And we download Buenos Aires City from the OSM terminal. And as a backup, I will use GitHub repository. Okay. So I hope that everyone was able to install Docker and Docker Compose. For now, it's necessary to have Docker from PostGIS with PostGIS and OpenMapTiles too. So in part block 1, we will create a folder where now there is we will create a folder FOSS4G. So here 4G. So now we have one. Then we will download the OpenMapTiles. We can use VJet. Yes. Sorry. My colleagues are right. I need to into my right folder, and now I can download the correct repository from tiles archive refs tax 3.12.2.zip leaf. Correct. So I'm okay. I've downloaded the project in this release. So I will unzip this file into this folder. So now I have folder OpenMapTiles / or -3.12.2, but I will rename it to OpenMapTiles. So now I have OpenMapTiles folder, OpenMapTiles. So now I have the project as in release. Now I will download the data. So there is a make file. So I will download. Now I am in this step. Will download from OSMFR area South America /China /Buenos Aires. YOL. So now I download the Buenos Aires city PBF. I show you in my folder OpenMapTiles, data, South America, China, and here is our PBF file. Next to it, it was create the bounding box of this area automatically. This file is around 9 megabytes. So this very small area. So we accomplish the first step. The second step is create extra layer. For extra layer in OpenMapTiles, we create new folder, cycleway, and we prepare four files. The mapping file, which is used by project Impossum to import PBF into the PostgreSQL. Then we will make some preprocessing data. Then we will create cycleway.sql, where is the main function which will be used for create vector tiles. And the last one is cycleway YAML, where is defined a configuration. Now I would like to show you how the cycleway looks like in OpenStreetMap. So we'll wait a moment. So this is cycleways in Buenos Aires. You see that this is a relation and have 1,000 members. This network or relation has name the red. Sorry, my Spanish is not good. The tag is road and bicycle, and type is network. This is good to know. And the second is what I would like to show you is this is one member of the whole relation. It's one path from the whole relation, and this member is part of two relations, which we need to figure it out in preprocessing, but also have separate name, separate surface, and I think that's all what we need. So, as I mentioned before, we will import a new relation for cycleways, and this is the one of the member. This is how looks the mapping file. You can find this file in the GitHub repository. Then you can use the hyperlink in codes for files, where the first one is the mapping YAML. I will show you here. I don't know if going bigger a little bit. Okay, so I would like to make some notes about this file. This file is configuration file for Impossum project. So it's a YAML file. So here is the top level tag, or how it say, and means that this create a table. Table will have a name, cycleway underscore line string. Or into Postgre database, the name will be adjusted by the OSM with underscore at the beginning. So in the database, we will have this name of the table. Under that, there is a type where we put the relation member. That means that we will create the table, the cycleway line string table from the relations. The next is columns. Here is defined what columns will the table in PostgreSQL have. The name is the real name in the Postgre database. So we have OSM ID, we have geometry, network. Here we will have member name, we will have surface. Why here is this separate value? That's why I would like to show you that if you have more tables in this mapping YAML, you can define the common fields, make definition of that field up, and then use the link, that name. The link is this one, this name. The another is type. Its type is identifier, geometry, string, and string for the surface. This defines the data type of the PostgreSQL table. The next, what is important is value from member. So this value will be in the database taken from, not from the relation, but from each member. In the database will not this network have only one OSM ID, but each line will have the OSM ID based on this one member of this relation. Member name, it's not the name of the relation, but it's taken from the member. So the member name line will have the name of the each part of the network. And the last target is mapping, which define in which tag, which value will from the PBF file will be taken into this table. So as I show you, the road bicycle is this tag road and this value bicycle. So I hope that I don't have to write this file again. I will just in layers. I will create a folder. I write the name cycle way. In this folder, I will create a new document, which its name will be mapping.yaml, and into this file I will, not very nice, but I will copy like this. You can also download the whole repository and copy the file. It's okay. I want just show you and explain what each line means. So this is the first step for import extra layer. The second file, we can create configuration which use it's a YAML, and I will show you in next slide what all fields it have. I will show you in the file. So it's cycleway YAML. There are three main targets. It's layer. I hope it's seen well. I will make a little bit bigger. Yeah, it's okay. So there is three main targets: layer, schema, and data sources. In the section of layer, there is ID. Very important, because this ID will with this ID, the whole layer will be identified in the vector tiles. This description is just text description of the what is in this map layer. The buffer size, this number it's a little bit more difficult, but the buffer size create one tile a little bit bigger to keep the name text, or if you have point or line and you have a text in the line, then it makes a little bit bigger than the tile itself to keep this text in full format and secure that the text will not be cut with the another tile next to it. The fields is definition in which fields will be in the vector tiles final in the vector tiles. So we have network, name, and surface. This description is the same like this one line. This pipe shows that there can be a multi-line description. So this is the same, it's just the description, but this network name and surface is important for the generate metadata into the MB tiles. So the network name and surface, which we define in the last file. I will show you again that in mapping we have here surface, we have network here, name, and the name is the member name for this, but we will adjust it in the SQL files. So again, yeah, cycleway YAML. So this is a field. The data source is defining which and what is really necessary to have it there is geometry field. What is name of geometry field and the query. Query is the main query which generation of tiles will asking this function to return these values from the PostgreSQL. To each bounding box is bounding box of each tile and on which zoom level. These targets are for identifier of each feature in tiles. The schema, it's a top target. We define which SQL files should be imported during the import SQL target, make target. So here we have as many SQL files we want. We have two. This is the main SQL with this definition of this function, the function layer cycleway, and this SQL file is for preprocessing. Data sources, there are two options. The type is InfoSum free, and mapping file where can be found the mapping file for the import OSM, which means which file should be taken for import OSM. That means import data from PBF file into the Postgre. So again, I hope it's okay if I not write it by hand, but only silly copy into the new file. These two files you can find in any other layer. For example, park. There is also mapping YAML for park, where in the lower section there is a table there is a arc polygon, type polygon, and settings of the columns, and which mapping tags or which tags should be taken from the PBF into the PostGIS. And you can also find this description where there is a function or query with the function like arc and the whole same definition. So we'll go back to Cycleway, another document which is called Cycleway. I will copy paste the definition from the GitHub repo and save it. Cool. So now a little bit more difficult to work. As I show you, these, for example, this member of the relation is included into two relations. So in the database, this line will be in database twice. So we need to get rid of it, only or merge it or make union of these the same line. That was a configuration layer, and to see step the SQL files. So we for manage this Cycleway layer, we will create two extra or two SQL files. One with the preprocess data, or one which will preprocessing the data, and the second one which create the main function, and one materialize view which will be used for zoom 8 to 12, which generalize the lines. If I go back to two extra layers, in this Cycleway merge SQL file, we will create two materialize view, one with name OSM Cycleway union line string, which will remove duplicates, and OSM Cycleway merge line string, which union the segments with the same name and with the same surface. I will go back to the repository where these two SQL files, the Cycleway merge and Cycleway SQL, is already there. You can use it. You can download it. This file will be executed in a step in a make target import SQL. If I show you in the steps of the OpenMapTiles project, so we already make configuration for import OSM, and now we will creating values for import SQL. These file, the Cycleway merge and Cycleway SQL, will be executed. So every line or block of lines, for example, this will be executed and run in PostgreSQL. This line will drop materialize view with name OSM Cycleway union line string if there is some of this. This line is because if we run multiple times with some changes, we would like to get rid of this materialized view. It is not necessary for the first run because the database is empty, but this line is just for sure. The next is creating of materialize view is this block. This target or this function create materialize view OSM cycleway union line string. It's if you look on the another layers, you will see very similar naming. So I will keep it as it is, but you can almost choose whatever name you want, but you need to make very strict renaming of other, but we do not in this workshop. So we will create materialize view Osmo cycleway union line string S, and now we have select which create the materialize view. The materialize view is better because it's better than a view, but it's no problem to create a table. But materialize view is better for this type of queries. So we will create materialize view where we select OSM ID. Then we'll make some processing on geometry, the member name, network, and surface. OSM cycleway line string. This table we import in make target, I think 4, import OSM. So this table is already in the database, not for now, but when we make when we will creating the make targets, it will be there. And because we collecting the geometry and creating a line merge and making a dump, we will group the lines based on OSM ID, network, member name, and surface. This will remove the duplicates from the Osmo cycleway line string. The second step is very similar. There is only one more step where we, I make a little bit bigger, where we create the index. The index is very useful and really necessary if you're working with geometry. So using GIS for geometry, it's indexing technology or function. So we create the index for the materialized view on the geometry. The second materialized view, same. We drop it if it exists, but for the first run it will not exist. We create the materialize view cycleway merge line string S, and also there is a select function where, because we merge the lines together with different OSM ID, we have to get rid of OSM ID number. In many cases, it's better to keep it OSM ID, but this materialize view will be used only for zoom level 8 to 12. So it's very far from the user, and it's not necessary to have it the OSM ID. In the next zoom levels 13 and 14, there will be OSM ID because it will not be using this merge line string materialize view. So we merge the lines together, group by network, member name, and surface, and also create the index. I hope that is everything okay. If I also just copy this file or this functions, this creation into the next file in the folder cycleway next to mapping.yaml and cycleway.yaml. This file should name cycleway GL and save as it is. You can see there is ETL dots on every materialize view. This is useful for generate documentation, and if you pass through these images in ETL diagrams, you can see how from the OSM Impossum 3, that's the project to import the data from PBF to Postgre, create the OSM cycleway line string. From OSM cycleway line string, I create OSM cycleway union line string. From this table, I create cycleway merge and also use this union into the zoom level 14. And it's sometimes it's very good to have a visual, not just some code. But back to the cycleway merge. I have cycleway merge, which this file is also mapped into cycleway YAML, where I define that this file should be imported during the import SQL file. The next file, cycleway SQL, define one function and one more materialize view. Again, more. So, as I mentioned before, we will import this layer into zoom level 8 to 12, 13, and 14. If I use OpenStreetMap, this is zoom 11, 10, 9, 8. This is the zoom where will be the end. From this zoom is not necessary to have all the precisions of the data. So for zoom 8, 9, 10, 11, and 12, we will use generalized geometry with merge line. But for zooms 13 and 14, we will use the original geometry with all the OSM ID and all the attributes. Again, into cycleway SQL. So in this file, there is another materialize view creation, which I create materialize view with name OSM cycleway merge light string generalize zoom 8 to zoom 12. It's a very complicated name, but it's better to keep it straightforward and clear for everyone. You can also add some documentation string and comments, whatever. This is the naming system for OpenMapTiles project. This is very clear and easy materialize view because I use OSM cycleway merge line string table from Postgre and import all the attributes. Only one difference between cycleway merge line string and this materialize view with the gen Z8 to Z12 is that there is a simplified geometry to resolution on zoom level 10. This is the spatial function which just calculate the pixel size on this zoom. So the geometry will not be too much generalized, but not too low generalized. But on this zoom level is okay. So this is very simple materialized view, but it's better to create materialized view, make the PostGIS database bigger, but without the creating and making some calculation during the final stage, which is generate vector tiles. So I don't want to create the generalized materialized view for every zoom. So now it's only one materialized view. Probably the best solution is to have one materialized zoom for zoom 8, one materialized view for zoom 9, 9, 10, 11, 12, 13, 14. One materialized view for generalized geometry, and using PostGIS function st-simplify. The second part of this file is the main function which will be called on every tile on every zoom. This function is a little bit larger. It's 50 lines, but there is a creation or replace the function, right? Where the import or input attributes are boundary of each tile and zoom level. This function returns table with desired attributes. In this case, it's custom ID, geometry, name, network, and surface. This table will be filled with data which are selected from, and this part is using for, how to say correctly, define which data from which table should be returned into the geometry and zoom level value. So every selection has some filter where zoom level is between 8 to 12. And these tiles we will return from the table OSM, cycle wave, merge, line stream, generation Z8 to Z12 with all the attributes. Because in mapping file we have member name as an attribute of the PostgreSQL table, we rename this attribute to name. I keep the member name because it should be more clear that this name is not taken from relation, but from the member of the network. So this where condition is on every selection. So we have 8 to 12, zoom 13, and zoom 14 plus. So if the generators will query this function, for example, some bounding box, it doesn't matter, but for example, for zoom 7, then it will not select anything because we don't. This selection will not pass through this filter. But from the zoom 8, it will select the data from this table and create from this data, from this table, new table which is returned by this function into the vector tiles. And so on. So 8 to 12, this zoom 13 will be taken from OSM cycleway merge light string, which this table define in the SQL file cycleway slash or underscore merge union this one. This materialize view. And if I go back to cycleway, well, it was for zoom 13, and for zoom 14 we will use materialize view awesome line string union line string, which was defined in cycleway underscore merge SQL file. We will use it this materialize view into the zoom. There is another condition where geometry meets the bounding box, which will searching for the features only in the bounding box of the one tile. So again, one more file to copy or create into our new map layer. Is cycleway.SQL, where I also copy all 70 lines of the cycleway SQL from the GitHub repo. Cycleway SQL, paste. Okay, save. The step 1, where we download OpenMapTiles and data, is finished. Okay. The second step, where we creating the extra layer for OpenMapTiles, is creating the mapping.yaml file, cycleway merge.sql file, cycleway.sql file, and cycleway YAML file. These 4 files are necessary to have it in the cycleway folder in layers. This is how it looks like the mapping file, the configuration file with the query, where we select the OSM ID, geometry name, network, and surface from this function, which was defined in cycleway SQL file. The preprocessed cycleway merge SQL file and the function which return on from demanded tile, the layer cycleway. So this was very hard, maybe a hard section for step 2, create extra layer. But I hope that everyone is finished, or at least copy the files from the repository. But I hope that my talk will help with the understand what the files do. The last step is import OpenStreetMap data into PostgreSQL with PostGIS. Before we run all the steps for OpenMapTiles, we need to make a little modification to three files in the project. On the end of the project modification step. So if I look into my project, I need to show hidden files also, because there is the hidden file .env. If I run this file, I need to modify two values. On line 23, there is a max zoom, which I need to modify to max zoom 14, because that data are defined to be in the zooms from 8 to 14. Another things on line 33, it's borders cleanup. It's also in the repository where the modification of env file, these two targets we need to modify, because some data like OpenStreetMap can contain invalid references, this is the case where we need to clean up the borders before we import it. That's only these two lines, 23 max zoom and border cleanup to true. It's only thing we need to modify in this env file. The second file which we need to modify is OpenMapTiles YAML, which this file is like the root file of where the all knowledge of all layers are contained. So there is a tile set which include layers. We need to include our new cycleway layer into this list of all layers we have in OpenMapTiles schema. So we have new folder named cycleway in layers folder, and here should be the configuration of YAML. So this name is very easy, cycleway.yaml, the same as any other. What next should be modify. We can also modify this version to 2. We can also modify this ID to 4G. It's better to do it for now for this workshop. And we also, it's on line 22 and on line 25 there is a target named center where we have 0, 0, but this center will be calculated from the file which was created during the download. It's this Buenos Aires City dbox file where is the boundary box of the data, downloaded data. So because one zoom it's x, y, z, so we modify this z file, this zoom file, not to be 1 but 10, because otherwise the metadata for this data will be very far. And for this file, it's all to modify. And one last modification will be for Docker Compose YAML. This YAML for better communication with the QGIS. In Docker Compose YAML, we need to change in service, for service Postgres, we need to change the ports from to make the Postgres the Postgre Docker to be able to connect through QGIS. So we need to map the port to 5432. How is it? Column, okay. To 5432. That's only one change in the file, docker compose YAML. Last step. So we change the OpenMapTiles YAML with adding the configuration YAML. We change the ID from OpenMapTiles to FOSS4G, and we modify the center zoom to from 1 to 10. We also modify the env file, the target border cleanups to true, and the max zoom from 7 to 14. We also modify the Docker Compose YAML for the Postgre target to modify the ports. So the last step is import all these data into the Postgre. So I switch to the terminal. I am in my project. When the first I will call make clean, which delete the old files now which are not necessary. So make. Basically, it will remove the build where there are prepared files for imports. The next target is make. So I create the files into the build folder. Oh yeah, and to this creation, I call make import borders, which import the border from the PBF file into the Postgre. Take a while. Maybe it runs the Docker Compose run OpenMapTiles tools, running the database, and importing the borders. Here is notice the table OSM border line string does not exist. It's because there is a drop table, but there is none. So the borders are in OSM underscore border line string table. The next, maybe a little bit more slower, is make import data, which import the stable stable datasets like nature Earth, or which are imported right now, or the ocean layer, which are taken from the OSM water project. Firstly, it was importing nature Earth. Second step is importing water polygons shapefile into Postgre, which is also necessary for the water layer, which is one of the layer of OpenMapTiles project. I hope it will be quick. Yeah, it was quick. And the last is center line for lakes. So now we will import. This is the main import OSM, which take the PBF and import all the layers which we define in OpenMapTiles YAML, the root. If you remember the list, right? Remember the list, which import all these layers into the PostGIS database. And because it's only 10 megabytes PPF, it took 15 seconds on my small computer for now. And for be sure, we also make import Wikidata, which import Wikidata into for the features which include the OS Wikidata ID. In this case, there are 818 items, which include some language translation for the feature. That was the last step of this block. I hope that you are okay and you are ready to go to next blocks. Thank you for your attention, and I hope you're okay.